All right, today we're going to talk about density. Density is one of my favorite topics. Density is the reason that you float in the Dead Sea or you might sink in the swimming pool. It's the reason that Archimedes is famous. He was the Greek scientist who measured the king's crown and realized it wasn't gold, and he did that by immersing it in water. And the density wasn't what he thought it should be, and he knew it wasn't gold. And he said, Eureka! Well, hopefully today's lesson will provide a eureka moment for you. I want to start here. I want to look at these three boxes that we have. So to understand density is to understand two properties of matter. The first one is abbreviated with a V, and it is volume. And it's the amount of space an object takes up. So we say amount of space an object takes up. So the bigger something is, the greater its volume. And then mass is the second thing, and it is defined as the amount. We could say matter. Some people say stuff. The amount of matter in an object. And density is actually defined. Density. Oh, misspelled it there. Let's go density. Don't judge me on my spelling. Density is the ratio of mass to volume for an object, and it is abbreviated simply as M divided by V. And let's take a look at these three objects that we have here. We have these three boxes. You can think of them as three pieces of metal, maybe three chunks of cheese, three pieces of metal, whatever. But these two have the same volume. I tell you they do, and you can look. You can see they both basically take up the same amount of space, so we say V for both of them. This box has half the volume that these two boxes have, so we call it half V. Now, we said mass is the amount of matter in an object. If we were to count, we would see that this box has 16 particles inside of it. This box has 8, and this box has 4. So for each of these objects, if we were to go over here, we could do this. We could say box 1, box 2, and box 3. Let me give them little numbers: 1, 2, 3. And we could say the ratio of mass to volume. And if you look, box 1 and 2 have the same volume, but there's twice as much stuff inside box 1 as there is inside of box 2. And what that means is box 2 is twice as dense. And you can see it maybe mathematically if we take the mass, which right now is in particles, 16 particles divided by V, and then 8 divided by V. So these two, you can see that this one has 2 times the density of this one. Right? This one is 2 times the density of the one below it. And the reason is because even though they have the same size, this box has twice as many particles as this box. What about this box? How does its density compare? Well, it has 4. So we go over here, it has 4 particles, but the volume is half as much. So it's 4 over 1/2 V, which you can simplify, and if you have a half in the denominator, you multiply the numerator by 2, and what you end up with is 8V. So these two boxes actually have the same density, which means that the ratio of mass to volume is the same. Maybe you can imagine if we cut box number 2 in half, right, and we just looked at 1/2. If we just looked at this half of the box, right, its volume would be 1/2, and it would have 4 particles, which is exactly the same situation that we have here. Now, another interesting thing about density is if we were to take box 1 and cut it into 4. So I cut it into 4 pieces like you see here. And I'm going to come down here to the bottom, and let's just look at one chunk of box 4. Or sorry, of box 1. One chunk. One chunk of box 4 would look like this, and it would have 4 particles inside. So the mass would be 4, but the volume for this would be what? It would be 1/4 V, right? If this is V and we take 1/4 of it, the volume of the little box is 1/4 V. Well, what's the density of that? Well, the density of that is 4 divided by 1/4 V, which again, we have a fraction in the denominator, so multiply the numerator by 4 to get rid of that fraction, and you end up with 16 over V. 16 over V is the same density that the box had initially. And what's interesting about this is that density is what is known. Density is an intensive property. And an intensive property is one that the amount of the object that you possess does not change that property. Color would be another intensive property, right? One piece of copper, if it's bigger or smaller, has the same color as the smaller or bigger piece did. Density is the same. If you cut an object into pieces, each piece has the same density as the bigger piece that came from it. We are in the next slide, we'll do a density practice problem, and we'll talk about units of density, but this video is to explain the concept of density. If you have questions, bring them to class, and I'll see you in the next video.